So today we're with Anna Cheniuntai at the world's first showroom for 3D printed homes. Anna is the CEO, co-founder of Appiscore. Thanks for joining us, Anna. Thanks for inviting us to your showroom.
Oh yeah, absolutely. Thank you very much for coming here. And it's a pleasure to meet you finally in person and talk about all of the excitement things happens in the 3D printing industry.
Yeah, we first spoke a couple of months ago and connected and talked about your university, talked about the history of this company. So tell us a little bit more about how do you get started? How did you find your niche in this 3D printing world?
Oh yeah, absolutely. So it was a pretty interesting journey to get to this point. So I started with the studying space physics. So I all the time wanted to be an entrepreneur. My mom was an entrepreneur.
It's in your blood.
Yes, but I didn't know what exactly I want to do. And while I were trying to figure out, okay, if I'm going to spend 5 years of my life studying something, it has to be very inspiring, interesting, and fundamental. This is how I ended up learning space physics. And closer to my last year studying at university, I met my co-founder, Nikita Cheniuntai. And so he already was in the construction business before, and he had a huge experience in robotics and industrial machinery, like a huge CNC routers, that actually he was asked to build the custom-built CNC routers. So he was very familiar and experienced with that. And so then we got the pretty massive contract for Olympic Games. We had to design, develop, and fabricate about 5,000 signages to navigate visitors across the Olympic Games infrastructure.
Wow.
So we basically were responsible for like 1 million of people not to get lost. Exactly. It was a lot of funny stories, of course. But the main takeaway that we took is that how outdated the construction industry was. We didn't really directly do the construction process, but we had to...
You got a taste of it.
Exactly, because we were affected by all of the delays in the construction. We needed to deploy the signages. Some of them were like a 2,000-pound big Stellas. It's only like the huge machine could install it. So, and sometimes we show up on the construction side with supposed to be the object supposed to be finished, and they said like, no, come in a week. Maybe we're gonna have it done. And okay, and then we had to play around the schedule, change a lot of our processes. And so after that, we made the first big money together. And Nick basically, we together saw that there is a room for construction for automation, because it was so outdated. And basically Nick invented this robot, basically coming from the kind of common sense and first the technical requirements. If you want to bring the innovation in the construction process, how it's going to look like and what problems it should solve, right? Yeah. First, it has to be very portable and mobile, because construction is all the time about the logistics. Yeah. Then it has to be very easy to operate, because we have a huge shortage in skilled labor. Yeah. And we need to have more people in the construction, so the entry
like you're lowering the barrier to entry.
Exactly. Yeah. And so this is how he came up with this unique design, revolutionary design. And basically this is how we started. And
one of the first ones in the 3D printing industry, because we've seen a huge explosion over the last 2 years. A lot of different people experimenting with different gantry systems, different types of robots and all, but you all started back in 2018, early 2019. So was it difficult to get people to accept what you all were doing, or wrap their head around the new robot? Or were people generally excited back then too?
So in the beginning, when you said 3D printed homes, they're like, what? No, it's science fiction, it's not going to happen. Although it's already what the company Winsun, they already experimented and 3D printed the panels and then assembled the houses with these panels. But back that time, it was so innovative, so real, the futuristic idea. And but then when we kept doing this, believing in what we're doing, then you could see how people are more and more acceptive to this, because we are also not the only company who were doing this. It was many other companies started like doing this project, this project, and then after our Dubai project, it was a completely like I think turning point in the industry, because it was not a tiny home, right?
Yeah.
It was not something just experimental. It was not something like a testing or like a small castle, something like this.
You all proved the technology
Exactly.
worked and you built a really huge building.
Yes.
So let's talk a little bit more about that building in Dubai. I mean, I came across it back in 2019, early 2020, and it's a massive structure. And it's really tall too. Like you said, it's an equivalent to like a typical four-story home.
Yeah, when you look at the building and like stay there, it's really tall, because every floor, it's 2 floors, and each of them is 4.5 meters tall. So yeah, it's very massive. And the material we extruded, it may be equivalent to like, I don't know, maybe 5, 6 or even more single-family houses. So this is really, I would say, a landmark project, not only for us, but for the entire industry.
What were the biggest lessons you all learned from the Dubai project?
Then the machine has to be more compact, more easy to operate,
and lighter.
And then like
lighter
too. Yes, and more like a mobile. So it was already very mobile, because you can easily move it with using the crane, for example. But now we have the advanced version of the machine that we developed based on that experience. Now the printer is mounted on the trackable Caterpillar moving platform. So now somebody like me can just use the joystick, and you actually can operate the printer and put it on the concrete slab, for example. So I don't need to use pallet jack. I don't need to use the crane or something like this. That's really like as a toy, basically. And another takeaway is that mixer machine, it has to be really different. We used to, back then, we used the standard plastering machine. It was a lot of pain, honestly, so it all the time was clogged. We need to spend more time to constantly clean it, because the 3D printing material, it's pretty sticky, high viscosity, it's a different type of material. And so after that, we developed a specialized mixer for the 3D printing. We call it Gary. It's not here, unfortunately, but that's really smart mixer that basically provide the consistency of the material, the way how it mixed, how the water is supplied. So, and it's also mobile. It's also on the trackable Caterpillar moving platform. So all of the units used to 3D print a house in our technology, it's all movable, very like transportable, and it's enough to have the standard flatbed trailer, for example, that can fit all of the 2 units. And then you just jump on a pickup truck and go to another construction site.
You all had fun with the names, didn't you? You all have 3 different size printers. Frank, that's the big one. And then you said the Gary is the mixing machine attached to the Frank. What are the other 2 printers that you'll have?
We have 3. So Frank, Gary, and Mary. Right. So Mary, it's a bulk truck trailer. Basically like a big rig trailer. And Mary basically can consist the material, 3D print material, dry material, that can be used to 3D print the wall structures of the entire 2,000 square feet single family home. So basically Mary delivers the material as a dry substance. Then it's basically you plug it with the Gary mixes it with water, and then it immediately goes to Frank to extrude it. So basically, you need 3 units at the construction site. And so we basically decided to use Mary, because otherwise you need to use big bags with the material. It's not really something that allow to keep the quality the same. And if we use Mary, the material never exposed to environment, never exposed to rain, for example, or humidity. So it's produced at the factory, loaded to Mary, and then it just got extruded through the Gary.
But if you have to refill Mary with additional materials, you'll do that in a controlled environment? You
basically, for example, the one Mary got empty on the construction site. Then the second Mary comes with the new material, like loaded
Yeah.
additionally. The first Mary goes to the factory and filled with the material there. So it's also the logistic part of the technology, because everything we do, we try to crack the code how to better automate construction and how to do this in the way so everybody can use it and it makes sense financially,
too.
yes.
Yeah.
Because you can create a great technology,
Yeah.
but if it costs a lot or it's not something that can be easily
Scalable
integrated
or
and scalable, it's probably never going to use.
It'll be a one-time hit and then it just dies.
Exactly. Yeah.
So you're trying to create something durable, something easy to use, and that's probably one of the main reasons why you all chose to build an expandable robot rather than the gantry system
Yes.
too. That's a big part of your company. That's a statement that you all are making.
Yes, exactly. So we don't believe in gantry printers, so it's not something that I want to hide. Because there is a reason for this. It's a huge logistics, setup, and operational cost. So it's basically the, huge structure that you need to transport. It can cost like $10,000 to transport the structure. But I know because I dealt with a lot of transportation before doing our projects. And then you need to assemble this on site. This is something that I completely do not believe. Because if you try to assemble something big many times from site to site, I think maybe first 2 to 3 times it's going to be pretty successful. But then I have no idea how it can continue to be durable solution.
Because
right?
there's wear and tear on all the joints when you're attaching, reattaching.
It's more room for errors.
Yeah.
Basically, with how we also see to rethink construction is to reduce the chances for errors. Because basically, this is where all of the construction delays created. With the 3D printing technology, we can create the very precise structure of a house, and then when you install windows, doors, which we call secondary construction, this is where you basically can fight for hours, minutes, and seconds, because you basically install it very fast. And this is where you can cut the errors. With the gantry printers, I don't know how it's scalable to train, people to all the time install this very sophisticated type of machine because it's huge.
Yeah.
So I don't see it as a viable solution to scale.
So you've also just identified human intervention, like you all are minimizing human intervention at all these different stages, whether it's opening up a bag of mix and pouring it into this, like you're removing human intervention there, or when you're taking the printer out of a truck, rather than humans manually attaching all the gantry system together. Let's remove humans from there, because basically humans are the main source of error on construction sites. Yeah, very interesting.
It's like, I really like the analogy of IKEA, right? Yeah. So first time you assemble something, it looks pretty durable, but if you want to assemble it many times after that,
good luck with that.
Yeah, good luck. Second, third time, I would not sit on the chair that I was assemble or reassemble many times. So all the time you unscrew something, it creates the room when you reduce the quality and reduce the durability.
Yeah. So I'm really, really impressed with this showroom. We kind of there's kind of an analogy to a Tesla showroom where you're making cars and an object of intrigue. So here with the showroom that you all have set up, it's one of a kind. I don't think there's anything else like this in the world. And people walk by and they see your printer at the window, they're intrigued by it, and then if they come in, you can explain how it works, and people are able to wrap their head around this new technology. And it's not so much as like in the beginning in 2019, if you were going to approach someone with the idea of 3D printed homes, they'd be like, what? It sounds futuristic. But here you're removing that barrier. It's not futuristic anymore. Here's a printer right in the shopping mall. Come in and talk to us about it. We'll show you how it works. Yeah. It's very unique.
Thank you. Yeah.
It's a great idea.
Yeah, thank you. It's basically came from the idea that how we can make the technology accessible to everyone, not just to use it, but actually to learn about the technology. Yeah. Because it's really, not many companies really do it, right? Of course, it's maybe like 100 of companies developing the technology, but how many companies you can visit, just call them, for example, and show and ask them, like, can I look at the printer? Can I look at your samples? Most likely you will hear like no, you need to sign NDAs,
yes.
and we cannot tell you what we're doing. So basically, this is what you can see today. But we want to everybody know what the 3D printing technology is about, that the printer that we use, it's really compact. Yeah. When people come in here, it's like, this is the machine?
This is it?
Or it's like the scale of the machine.
Yeah.
We're like, no, this machine was very busy last year. You can see the concrete on it.
Yeah.
And so the funny thing is that basically kids, the ones who notice the machine on the window and say like, oh, mom, I saw it. It's the 3D printing machine that built houses. And parents typically like, what are you talking about now? And they like, grab the hand. Now we need to go inside. And then parents like, wow, this is so cool. This is so unique. I had no idea that it actually exists. So our goal, even like with the Episcore University, is to really bring the awareness about the technology so everybody can know about this. Because the more people know about this, the easier for us and for everybody who work in this space to really promote the technology and put it on the actual construction sites.
More knowledge sharing,
exactly.
And like everyone grows together. So when did you all start Episcore University? It's just an online course right now, correct?
Yes.
Do you all offer any physical courses too, like in-person courses on how to operate the machines?
Not yet, but it's like in the roadmap of Episcore University. Because we also want to make sure that people who operate the machine, they're really trained, they're
serious about
exactly.
it.
Exactly. Because it's really important to make sure that the final product is upon the quality you want and nobody breaks the machine. And at the same time, we want to provide more opportunities for our future clients so they can send their employees anytime to Episcore University and saying like, okay, I have 2 operators today, but I just hired new one. And they send it to Episcore University, complete the training how to operate the machine. And this is the value for our customers, right? Like a business value for them. Yeah. So we can help them to grow and scale when they use our machines. Yeah. But so far we actually had a practical workshop last year in September. Oh. So it was a one-day experience when first half of the day it's more like the theoretical lectures when we tell a lot of information that probably not available online. Because when I read something online, it's typically written by people who never 3D printed a house. Like me, for example, I was in every single project we did. So, all of my hands was dirty with the concrete all the time. So I was like, okay, probably we need to actually tell our story, right? From the experience that we received. Not trying to kind of over-promote or like trying to tell that other companies like not so good as us. You're
just teaching about
exactly.
3D printing as a whole.
Yeah, we provide what actually happens right now, what other machines, what like the potential applications. And in September, it was the first practical workshop we did. And the second part of the day was the live printing. So visitors can see how robot operates, how they actually extrude the material. They can play with the just freshly 3D printed layers. It's really fascinating because you see that it's really a different type of material, all of those extruded layers. So, and we plan to do more workshops in the future. So, yeah.
But right now it's online courses and it's structured so that people, what's the content of the courses? People know about the materials and how they mix or how they perform?
So we have 2 online courses. So the first one is Fundamentals of the Construction 3D Printing. That's designed for people of all level of experience, like for, I don't know, designers or who never 3D printed anything with the plastic. So we just want to provide the fundamentals about the technology.
So things like XYZ coordinates, layers,
yes,
things like that.
Yes, okay. Or like how the 3D printing technology compared to traditional construction, to modular construction. What the basics of the material science of 3D printing material, how it can be produced. What about the geopolymer? What else we have? A lot of really basic stuff that we know that people went through this and say like, wow, that was so helpful.
I didn't
Because
know
now,
much,
I know much more. And recently we released second course. It's first part of second course, construction 3D printing from A to Z. So in that online course, we speak more about how to actually 3D print, more like a practical thing, construction documents, the structural integrity. So it's more practical.
Okay.
And this summer we go into release second part of second course. So it's going to be even more practical. So
Very exciting. So do you have any upcoming projects?
yes.
Plenty.
So this year we basically planning all of the projects for the next year.
Okay.
So we have affordable housing cooperative program, and we already have 3 partners that we have worked under this umbrella. It's the affordable housing group in Miami-Dade, then the Eden Village in North Carolina. So they build homes for the chronicle homeless people or somebody who really struggled to get the affordable housing. It's in North Carolina. And also we have the partner in New Orleans, Louisiana. So they really build, they are the construction company, and they see the need of affordable home in their area. And this is why we work with them, because they are really familiar with what has to be built there. Okay. And so this is the 3 projects that are already lined up. We also going to announce our cooperation with the Austin-based developer. So they build luxury homes, but also they have to have affordable homes in their developments.
Yeah.
And then...
So are they going to be using the printer for both the luxury and the affordable?
Yeah,
Right.
And the goal is not just to go and print one project. It's really, we really select partners that can help us to grow.
Like long-term.
Exactly. And basically, affordable housing cooperative program is that, okay, this year we spent to really figure out what we need to build, because the design and architecture in Texas is really different to Florida, and people have a different mentality. So before we start printing something, we have to make sure that it's going to make sense for people living there, and also that we can meet the target price. For example, our cooperation in Miami-Dade, they want to build homes for $88,000, right? That's pretty tight budget. But however, with the 3D printing technology, we can figure out how we actually can achieve it. Because with 3D printing technology, it's not only how we change the way of build the walls, we also can do a lot of value engineering, get rid of dry walls, for example, because we can put insulation inside, or we can optimize the infill of the walls, or we even can bring more other construction technologies, how we build roofs, how we build windows. So we really spent this year to design this for every cooperation we have, and then build. And then see, okay, we do this, what we learn, maybe it's still something to improve. And as our company grow and scale, we're going to bring more projects with them. So it's really like a long-term, very thorough thought cooperation roadmap, I would say.
It's really nice that you've identified, not just around the world, but in the States too, like every area has a different design requirement, different expectations from the people who are going to be living in it. And that's so important, because you can't 3D print the same house in Texas as you would in Florida, or in Florida the same house that you'd print in India, like you mentioned that earlier. And that's a really important part of your business, because you were approached about the idea of 3D printing in India, and you observed how construction goes on there. Like they first 3D print, first they build the structure, and then they come in with the infill walls. And you told them 3D printing is not compatible with that sort of building technique. So that's a really important part. So even when you all are designing these homes in New Orleans, and you said Carolina too, you'll have to design very different kind of homes in
exactly. So yeah, we try to tailor the technology for the specific project requirements, project target price, and design as well. In Eden Village, for example, they need to have individual tiny homes per person, right? In New Orleans, you know, the architecture in New Orleans is so beautiful, right? It's completely different world. You cannot bring there just a cookie cutter house, for example. So you also need to match their landscape, how people think there, how they're kind of like a feel, right? So that's a different story, and different target price. In Miami-Dade, it's also a different story. So yeah, that's really exciting, and this is what we basically want to do, not just come and print. It's really more just to build faster and cheaper.
So do you all work with the local architects, the local interior designers, and tell them what can be done with your machine and what can't be done, or do you all design homes too?
So I would say we do both directions. So far, we basically designed really like a in-house, except the Impreza. So Impreza is the concept of the 3D printed home that was designed specifically for the Space Coast. We worked with the local home designer who came up with this idea and Impreza architecture style. But before, we basically did everything in-house, and we're still doing this. So Trevor Ragno, our director of construction technologies, he also a great architect, without degree maybe, but he actually working on a more concept that's going to be introduced soon. But we also plan to work with the architects. And of course, it's not going to be just random architecture firm. We have to really select who we're going to work with, because it's actually the intersection between the practical world and the design world, right? So you kind of need to be very, understand the balance, so what you design, it can be built.
You can't design something absolutely crazy with crazy facades and stuff because it can't be printed. So,
if you have a lot of money, probably.
So y'all recently had a public funding round approved by the SEC, is that right?
Yes, correct. So we have been qualified by SEC to sell shares directly to public, both to accredited and non-accredited investors. It's not the IPO, but it kind of called pre-IPO, because everybody can participate and everybody can buy shares of Episcore just with the little of $1,000. So that was the idea behind this, that we saw a huge support from people who believed in this technology, and we thought that we want to have this opportunity for everybody, right? This is the beauty of Regulation A+ that we're doing, that now the such an incredible investment opportunity can be available for everyone, not just for the people with the deep pockets. And you may not know about these deals because it's all the time behind the closed doors. And so far it was so very wild. So we're really happy to see that people really happy to participate in this.
So you had a really good response from the general public?
Yes.
That's awesome. Yeah. So. All right. So what are you talked about your future plans for the rest of this year. What's your long-term vision for this company?
So we position ourselves as a technology provider, I would say, when we basically provide our robots to the construction companies, home builders, or developers. Because our technology is a tool for them, how to increase productivity, how to build faster, quicker, and with the better quality. So basically our goal by 2027 have about 400 printers in operation, so they can be in the hands of the construction companies and they build more and more. So basically this is how we see it to expand the industry. At the same time, this year, next year, maybe the the year after the next year, we're going to do our penetration strategy, when we're also going to be involved in the actual construction.
Okay.
So
in the short term, until there are enough people educated
Yeah.
and skilled enough to use the machine, you'll have to still assist in the printing, but your long-term vision is to build as many machines, as sophisticated machines as
Yeah.
you can, and sell it or rent it out to the
Exactly.
industry.
And we see that the penetration strategy is really, really important, because we don't want to just everybody use the machine and like don't care what actually happens after this. So we want to find the first early adopters who understand the learning curve, and they want to be basically to explore everything with us. And then we kind of expand. It's basically how the new technologies really brought to the market. First, it's just only you using this, right?
Yeah.
Nobody trusts you. Then you have like your early adopters. They still understand that the technology is new, but they're okay to invest in this and learn it and be with you. And then it's basically how the curve grows. And then you basically have just a general market. So we kind of here. Yeah. And this is very important. Who's going to be the first early adopters? So.
Well, that's really exciting. Thank you again for inviting us to your showroom and showing us how the Frank and the Gary and the machine, the Mary work. Looking forward to seeing Apiscore grow and print more
thank you very much.
buildings around the world.
Yeah, so I think next year, so I will be happy you visit our projects, and I hope we can do more
Absolutely.
videos like this.
Yeah.
That was the pleasure. Thank you very much. And I really like your YouTube channel, because you really talk about a lot of different innovations in construction. And I really like it because construction technology is something that doesn't really experience innovations in every aspect. So how we manufacture and install windows and roofs, it's still like something that we have been doing for like 100 years so far. It kind of works. Don't need to change it, you know. So yeah, I think that knowledge in the construction technology in general and new innovative technologies in construction is really important. So not just 3D printing.
Yeah, I agree. Just more discussions, more sharing, more knowledge, and we need more people thinking about the future of the industry.
Yeah. Thank you very much.